So, good morning from Germany, good afternoon to Bangkok and Southeast Asia. Welcome to our latest edition of the Beyond Mobile webinar series. Today's topic is 5G and future mobility. Can you show the chart, please? Thank you. And this is part of our road to Beyond Mobile, which we're inaugurating in Bangkok in June this year, which is a show on 5G and how 5G and the 5G ecosystem is kind of conquering businesses and kind of needing reactions from business all over the world. So our topic in June will be the network economy, unlocking the potential of the IoT area. My name is Mark Wächter. Next chart, please. Okay, you are too quick, guys. So then 2 charts back. Can you go back in the charts? Okay, my name is Mark Wächter. I'm the kind of chief evangelist, so to say. I'm the strategic advisor and content creator for this show, Beyond Mobile. So next chart, please. And then the next chart, now we are in order. We are really pleased to have Nokia as global launch partner, platinum launch partner for this show. We also want some other launch partners. Next chart, please. On the British Embassy, the Rohde & Schwarz company, True 5G. So keep with us, stay with us for other launches of partners soon. The show is in June, as we said, but we thought we're doing this series of webinars. Next chart, please. And today's webinar on future mobility is one we kind of planned a long time ago. We did already smart city, we did manufacturing, and we did health. And we also will launch a series of physical meetings in Bangkok, starting from this month. I will tell you later. And this all is part of the roadmap towards Beyond Mobile in June. Next chart, please. Can I have the next slide? Yeah, thank you. So first guest today is Sanpech Tangsavapark. He is Vice President for Industry Promotion at the Electric Vehicle Association of Thailand. Sanpech will dive into the topic from a more general perspective, and then we have 2 more guests, and after that we go into a panel. So Sanpech, stage is yours, next 10 minutes. Go ahead.
Thank you very much, Mark. Just make sure that everybody see my screen in a minute, please. Okay, so good afternoon, everybody. My name is Sanpech Tangsavapark. So I represent the Electric Vehicle Association of Thailand as Vice President for the Industry Promotion. It's a pleasure for me to be invited to this event organized by the VNU Asia Pacific on the 5G technology and the future of mobility. I will talk about 3 topics very quickly about EVAT, who we are in Thailand. And secondly, I will talk about the 5G and how it kind of it is involved in the future of mobility as now it is commonly known in the industry, and a short note on the challenges. Let's dive into the EVAT section. So EVAT is a non-profit organization. The objective is to reduce air pollution and to improve the energy efficiency in the transport sector. Primarily, we focus initially on the 4 wheels, but now we are getting a lot of requests, questions on 2 wheels, 3 wheels, buses, and trucks. We haven't got questions on drones yet, but maybe you would get those very soon. We are providing also consultations on industrial related matters, regulations, and standards within Thailand. We've got works on academics, user support, and also R&D. Basically, we've got a membership of around almost 300 people, largely from corporate members, within Thailand, and to a certain extent, some of the members within ASEAN region. So a lot of these are OEMs, traditional OEMs. We've got energy companies, we've got government institutions, and we've got also basically the ecosystems about the EV within Thailand. And we've got also individual members, around 99 as of September last year, mostly academics. So we are very much recognized by the government as a kind of trusted partner in terms of advices within Thailand for the EV domain. Let's go to further in about the 5G. So this is somewhat of a consensus now in the industry. This is case or S for some people who might say it otherwise. So this is a study perhaps 4 or 5 years in the past by McKinsey, talking about the future of mobility. A is for autonomous driving. Here, 5G would be the most significant factor in terms of infrastructure. I would dive this on this part for most of the session today. Second is on connectivity. C. Here we're talking about basically smartphone on wheel. We could, if cars becomes autonomous, we can see people drive without having to drive, and then we would spend time perhaps in meetings virtually, or even in terms of 3D holograms, and here 5G would comes into play. Electrification, so we know that now it's almost everywhere. HEV for hybrid, plug-in hybrid, all the way to fuel cell, and we might expect smart grid infrastructure disruption in the future. And lastly, the shared mobility. Here we've got cases all over the world in terms of shared mobility. Here is a kind of a question mark on whether this trend would continue, and this is to be seen in the future. In terms of the autonomous vehicle, SAE, which is the Society of American Engineering, they've defined the autonomous level of vehicles into 5 types, from 0, no automation, all the way to level 5, which is fully automated in all conditions, in all weather and traffic conditions, etc. We are perhaps the level of number 3, somewhere, let's say 2, 3-ish. Level 3 is where we've got a kind of a semi-automatic acceleration, some changes of lanes, etc. But most importantly, we are perhaps technically speaking level 4 in terms of technology. Here we are seeing cases in America, in the United and in China. Here the cars are driven by itself without drivers in ideal situations. So we are relying more and more on, let's say, automations. And here, this part where the 5G comes into play in the future. In terms of the automation in the future, we rely on sensors all the way into the AI algorithms. From detection devices, we rely on cameras, radars, lidars to detect objects, to determine the speed and distances, etc. So this is the data collection part. And then everything is captured and calculated by the AI algorithms, the CPU on board, basically. We've got cases like Tesla, we've got cases like Waymo from Google. And I've heard that in Beijing, they are going to showcase the autonomous vehicle without drivers. Basically, AI is still learning. It is still learning with the conditions of developing countries within ASEAN or even in some cases in the world. Basically, a single autonomous vehicle can drive by itself without the 5G. We can say that. For instance, it can go into, let's say, remote places. But once we imagine a city with all over with autonomous cars, here we are talking about 5G importance, where the cars need to talk together. So basically, it would be the world of machine to machine talking to each other. Here we're going to start. We're going to see one day that we're going to start perhaps looking at standard protocols. in the future, what we can expect. So I think some of the cases is not even the future we are seeing today. First is the smart city. In the scope of renewable energy, we can see the potential of solar and wind plus the battery, the optimization of energy and distribution and usage, and EV cars and or drones can be part of the ecosystems. We can see that there's already an auto industry disruption through EVs, and we would soon find the energy industry disruption in terms of smart grid, and we might find also a new technology like hydrogen, which is still which is still maturing. We can see perhaps in the soon future, let's say police enforcement with real-time road accident detections, solar vehicles detections, and 5G would be an enabler in terms of the infrastructure. Talking about challenges of all this in the future, what I can personally see is that there are two types of challenges. First, in terms of the adoption challenges, what I can see is that it is perhaps not the technology of the AI itself, but in terms of regulation, which become more important. Road accident happen all the time, even fatal accident in advanced country. But once an autonomous vehicle has a road accident, has a fatal accident, it becomes a very big headline. And here it is very difficult to find who is at fault. So here's a lot of discussion and debate on who's at fault. There's also maybe an ethical question, whether if there's an accident, the choice is to hit a child or should hit an adult. What is the choice from the, let's say, the algorithm point of view? This kind of question is being asked. We also face the question of standardization. So if the city is full of autonomous car, we need, of course, the 5G infrastructure. We would need standardization in terms of protocols. Perhaps we need a smart city platform where everything is linked up and hooked up to the energy platform, to the police platform, etc. So these are the questions of the adoption challenges in the future. I believe some of the questions are being debated, and a lot of thoughts are being given to these questions already. More importantly, the other kind of challenge that I see is the individual country challenge. I'm talking about here the people knowledge about AI versus the reliance on the home country's tech. Basically, 5G technology has been with us through the communication technology history for several decades. But AI technology is still very, very new, perhaps over the last 10 years. And a lot of this knowledge is still resting with the mainly academics and a lot of this to the high-tech companies. So a lot of, let's say, developing countries are facing this challenge, how to get the people up to speed in terms of knowing the technology and using the technology. Otherwise, we would be relying on the, let's say, the home country technology, being China, Europe, or in United States. Here I end my, let's say, quick introduction from the general aspect. Thank you.
Awesome. Thank you, Sanpech. Exactly what we needed now this afternoon, because you gave a complete overview of where we are. So we're still driving level 3, I learned, yeah.
That's a kind of the government. What is the government is allowing officially?
Yeah, of course, and of course the step from level 3 to level 4 will be a big one. Yeah, once you kind of get off the steering wheel. Okay, thank you very much. We talk later in the panel. So next on stage is David Goh. He is Vice President and Managing Director of the Asia Pacific PTV Group. Sorry, he is of that region, Asia Pacific for the PTV Group. David will talk about the disrupting industry models, business models in the 5G and context of future mobility. So David, your turn.
Humans have continuously innovated and adjusted our environment. the history of technology has evolved over the years immensely. We often think of technology as the latest innovation designed to enhance our day-to-day experience by creating a future that is smarter and more sustainable. But at the same time, we also see many other companies and even countries as well have tried to tackle issues such as decarbonizing mobility to address climate change. Government policies have been rolled out in cities to reduce emissions from urban transportation that is critical to climate change. Let's look at it from a traffic congestion perspective. Across the world, people lose billions of hours and money and dollars due to traffic congestion. So according to transport analysis consultancy firm INRIX, back in 2019, a driver in Bogota, Colombia lost about 191 hours annually, followed by Rio de Janeiro, 190 hours, Rome at 166, Paris at 164, and London at 146. Moving to Asia, the average driver in Thailand lost an average of about 56 hours, and Indonesia, which comes next, at 51 hours. I remember my pre-COVID days when I tried to hail a taxi in Bangkok during rush hour was faced with many rejection from the taxi drivers. In many mega cities in Southeast Asia, traffic has worsened much that even taxi drivers do not want to make the additional trip due to the congestion. In this race against urban density and traffic congestion, how would we change technology to provide the best way to tackle chronic traffic? My name is David Goh, VP and Managing Director for PDV Group Asia Pacific. I'm a lifetime learner of cities and how technology can improve the lives of cities. I'll be sharing some interesting city use cases and how 5G can be used to enhance transportation and mobility. Feel free to connect with me if you want a deeper exchange. Disruptive technology like 5G bridge communications between vehicles and infrastructures, bringing fast network response and connecting speeds. It is reshaping the urban planning and traffic management system industry to enable smart cities to improve their livability and sustainability. Across the globe, PDV Group has enabled more than 2,500 cities to better traffic and transport planning. We have also enabled some with smarter traffic management system. Let's take an example from Asia. Taipei is battling with the most challenging threat in their lifetime on the advancement of global warming situation. New Taipei City, with a population of 3.9 million residents, has 94% of them living in urban area. The number of vehicles on the road has also multiplied over the years, with motorcycle amounting to over 2 million. And the latest statistics where the sales of new car vehicles hit a 15-year all high in 2020, despite the pandemic. No doubt that has tremendous environmental impact on the road and traffic condition. To ensure smooth flowing of traffic in its business district, in 2019, Taipei, the district of Nangang Nihu, decided to use PDV Balance, a smart adaptive traffic signal and real-time traffic solution to optimize traffic flow, thereby reducing emission and vehicle delays. Based on real-time traffic flow data, they can then quickly react and adjust to what is happening on the road. The smart traffic light even go one step further by automatically designing a range of signal control options and sending these optimized signal plans to the local controller in a 5 minutes interval. This has resulted in an average travel delay time improving by 13% and a significant reduction in CO2 emission and fuel consumption by up to 10%. Let's move our focus to the west central part of Taiwan, Taichung City. Taichung City has been suffering from heavy congestions for years, not forgetting that it is the third highest populated city in Taiwan with a population of over 2.8 million. According to Tottenham data on Taichung traffic, just by driving during the congestion in peak hours for the year, this easily amounts to 126 hours of congestion. To relieve the worsening traffic congestion, Taichung City government upgraded its ITS system with a real-time solution that predicts the traffic level almost instantaneously. In 2018, Taichung City also won the Distinguished Honor Awards as its best ITS project in Taiwan for its real-time traffic prediction system. Such results are proven with the convenience offered to the driver for them to reach the destination in a shorter time. With the enhanced network capacity, it has really reduced the journey time by about 9%. Average traffic speed has also improved by about 8%, and total vehicle flow increased by 7.6%. Shifting our focus to the other part of the world in Europe, Spain, passenger levels are a long way to pre-pandemic benchmarks ever since the imposed restriction in March 2020. Madrid Metro recorded an average daily journeys of 1.4 million for the first few weeks of June 2021. Perhaps due to the results of the end of state of emergency for COVID. Just for reference, in pre-pandemic days, they recorded 2.2 million journey per day in 2019 and 830,000 in 2020. The reason behind this is also due to the government guidelines where only essential travel is encouraged, and hence the result of change in public behavior. How does transport operators like Metro de Madrid adapt to decreasing capacity, demand, and social distancing in an efficient way while maintaining a high level of service? Metro de Madrid adapts the decision by predicting passenger density based on pandemic restrictions. To do this, they identify, analyze, and predict changes in commuters' behavior to better plan their transport capacity with PDV Viso. In a survey conducted by the Spanish Consumer Protection Group, OCU, 31% of Spanish consumers consider public transport as the most dangerous place because of pandemic. To address the high-risk perception associated with transit, public transport planners and authorities need to bounce back with viable solutions to change this perception to ensure that the cities will not be overloaded when returning back to norm. From the passengers' experience, their journey is now enhanced as they can get more information such as train waiting time, capacity limits in real time, ensuring safe social distancing and allowing them to plan their journey, timing, and routes via the Metro de Madrid app. But of course, these are based on historical data and predictive model. With 5G network, there is increased visibility and control over transport systems, and this information can get to the end user much quicker and faster, thereby improving how people travel around. The highly responsive and reduced latency features of the 5G network will transform almost every single walk of life, giving a more robust and enhanced visibility and control over mobility. At PDV, with over 40 years of technology experience, we constantly improve our offerings to address the needs of many cities in the space of traffic management, transportation, and logistics. In today's fast-moving world, real-time data is essential to optimize operations and making cutting-edge decisions to instantaneously to win. Data has become more critical than ever before for government and businesses. Public transport controllers can use 5G network to connect people with an intelligent and integrated mobility systems with smart buses or subways, creating a whole new mobility experience. With visibility of people movement and traffic, 5G enables cities to plan day-to-day traffic flows and predict the mobility conditions around large events in real time, translating into more efficient and reliable mobility offering. In conclusion, there is no doubt the rate of change has been tremendous for the past half-century. With the digital enhancers and 5G solutions, there will be rapid advancement, and this growing rate of change will improve the lives of individuals and businesses. This is where smart cities come alive with the transformation of urban transportation and its ecosystems from governments to businesses and to residents. I believe all of us will be equally committed to providing the best condition for cities to be safer, smarter, and more sustainable. My name is David Goh, and thanks a lot for listening in. I'd like to thank Beyond Mobile for organizing this and having PDV to share. I shall now hand the time to the next speaker, Mr. Sharma.
Thank you, David. Awesome. I learned something new about traffic management also for pedestrians, which is also a promise of 5G and the low latency. Excellent. So last speaker of today, and then we jump into the panel, is Kavshol Sharma. He's principal engineer at Continental, or as we say in Germany, Continental. Kavshol, your stage, 10 minutes, and we are looking forward to your insights in V2E or V2X communications.
Good morning and good afternoon to everybody. My name is Kavshol Sharma. I'm from Continental Automotive, and I would like to introduce you with 5G enablement, how a real-time vehicle to anything communication has become possible, and how it is going to make driving for commuters very safe. I have divided my presentation into 3 parts. One, I will quickly go through what 5G brings to the table. What are the radio interfaces in the second session, and third session, I will tell you the vehicle communication impact and how what are the use cases which will make 5G will enhance which use cases to make the commuter safe. And also it's not only commuter, it is going to make safe commuters, pedestrians, the whole mobility to talk about. So first, in a brief, what 5G brings to the table, I think it is very well known to everybody, but I would reiterate them. The latency in 4G network is 10 milliseconds. The latency is in 5G network is going to be 1 millisecond. The data traffic was about 7.2 exabyte per month, which is going to be 50 exabyte per month with the higher bandwidth. The data was transferred at 1 Gbps. Now it is going to get transferred at 20 Gbps max. And the spectrum was 3 gigahertz in the beginning and in the 4G, and now it is going to be 30 gigahertz. Last but not least, basically per square kilometer, there used to be about 100K users connected. Now it is going to be about 1 million users per square kilometer can connect. And these enhancement basically will bring a lot of innovative use cases which can enhance the life of a commuter. So in nutshell, higher system capacity, higher data rate, reduced latency, massive device connectivity, and energy saving and cost reduction. So basically, this is what 5G brings to the table. 5G is deployed by 3GPP, and they have different releases. So these features are getting enhanced, and they depend upon technology. So the delivery and the users will be able to use them with the different releases. So about release 16 is already in operational. Release 17 it will get operated in some countries depending upon the deployment and the reuse or the deployment conditions. They will be deployed by the countries and should be available. With this, we go and see radio interface. The radio interface is generally defined by World Radio Communication Conference. In 2000, they defined 3G. In 2007, they defined 4G. In 2019, they defined 5G. What they really have added here is 2 frequency ranges. One is sub-gigahertz range, which is usually current range, what I would say, and there will be something to be on 24.25 gigahertz to 52 gigahertz. That is a millimeter waves. Generally, that is referred as new radio. I just wanted to introduce where it is coming from and how it is deployed. The enhancement I would like to just follow up with so that I can refer them into the use cases. The important thing is it reduces basically the basic need of the beam forming, creates the MIMO more possible, more bandwidth can be allocated. The power limitations are solved by supplementary link, which is uplink rate are limited in this situation, but the power is improved. The most important feature, which is useful for the next session, what I'm going to talk about, is the new way of transmitting the communication to reduce the latency, and that is basically there is a micro slot or a mini slot traffic, which is a new thing in the 5G, which will bring the latency to be very low. That's a protocol enhancement. Then there is an enhanced control channel for the robustness or the robustness issues. So these are the few very important enhancement that 5G brings in, which are very useful for the V2X communication. Next session, I will talk about the V2X communication. So when this term is used as V2X, is basically vehicle connected communication, and X is used for the to notify, saying that it can communicate to many other things. Thereby it is below you can see there is a V2N, vehicle to network, vehicle to vehicle, vehicle to pedestrian, vehicle to device, or vehicle to grid. So these are the generally terms used, but V2X is a common term used for all these things. This will enhance vehicular communication services, including both direct communication between the vehicles and vehicles, vehicle to pedestrian, vehicle to infrastructure. It will improve all of them. And the use cases will mostly focus on safety, intent sharing, path planning, coordinated driving, and real-time local updates. So these are the things the use cases which will improve. V2X is not a new term. It is basically already in force. It was used by short-term DSRC, which is basically a short-range communication. It is defined by IEEE. It is in 5.9 gigahertz, and it was primarily built on 802.11p communication, which is wireless access and vehicular environments wave. That's a standard by IEEE already, and it was used. There were some limitations with this. We will go in my next slide with the limitations for this, but the new method which is coming to do the same thing for the CV2X is called cellular vehicle to everything, or V2X communication. It is basically designed to improve the road safety and achieve the efficient traffic flow, reduce the environment impact, provide the new useful services to travelers. It uses ASN.1 control pipe signaling protocol for transmitting. And basically, it will enhance the same services which are provided by 802.11p and DSRC, but they will be improved. Going to the next slide, basically the 802.11p and the new thing which is improved is called EDCA. Basically, this is the term used by 5G for the same action what usually is done by 802.11p. The drawback for 802.11p is basically the strategy used for the medium access is CSMA by CA, which means that collision avoidance. Basically, what it does, it means is that it listens before it talks. So basically, if there are multiple people or a huge amount of gathering is there on the road, and there are people talking more, then the chance for the vehicle to get access becomes very less, because it listens. If there is nobody talking, then it talks. So it means that there are higher number of stations transmitting in the certain area. The probability that the station postpone the transmission as a result of the channel is being occupied. So EDCA basically tries to avoid this, to improve the situation by higher number of connections per square kilometer, which I have already explained in my first slide. I think it is 10-fold increase. Plus the 3GPP long-term evolution that is evolved universal EU TRAN. What it really does is that based on the priority of the based on the priority of the signals or the priority of the communication, while both the cars are communicated on the network, they will remove the CSMA CA. Basically, What they will do is basically based on the priority in the QS class parameters and performing an admission control, they will remove the CSMA-CA. So that means the communication between two cars will become flawless. They will be able to get right communication, and there will be an improvement into a disaster management. Latency is already improved by the 5G, and that will make the life or the safety more enhanced for the pedestrian, commuters, drivers, and almost all the mobility section. I have pictorially shown how it really happens, and if you see in this coverage here, basically when both the cars are connected, and let's say there are two cars at two different places, they get admission control. So basically, who's going to talk to whom is defined, and then they use this 5G also provides a side link called PC5, which is same 5.5 gigahertz range communication signal, so they can talk to each other directly. But they are talking to each other directly. Two cars are talking to each other directly under control of the coordinator, which is basically in the network, and that is how they improve each other's communication and make multiple communication possible, and the road safety better by guiding them to communicate to the right vehicle in the right area into the right scenario. Going further, I would like to show what are the use cases which will bring this things into the perspective. Generally, we try to divide this in use cases. There will be multiple use cases, but these are the use cases which are very highly talked about. So basically, high density platooning, or see-through sensor, or teleoperated driving, or a map update for highly automated driving. So these are the general use cases talked about 5G. The last use case can also happen in 4G and 5G, but 5G will improve the thing. And so these are the classes of the new generation mobile network and this technology roadmap. You see this MCC will be handled by mass critical communications. Basically, when there is a critical, so for this use case is the V2X usage. What is the important thing? The important thing is mission critical communication. Or if you take the other use case, basically where you want to do a teleoperated driving, then basically the MCC or mission critical control is also used. Whereas see-through driving basically uses massive machine communication. Basically, see-through driving means that two vehicles are going to communicate and share each other's sensors or a perimeter, or basically perspective what is seen by them, and that needs a huge amount of communication. So they will be handled with that. Generally, other parameters I have mentioned here is like reliability of the communication, what is required, the number of connected devices, just like in platooning, probably less number 10 devices. In vehicular communication, usually there is a safety standard ASL, and I have indicated generally these communications will be covered by the standards for the ASLA. Generally, ASLA, ASLB, and C are the type where how critical the communication is informed. Then there is a basically bitrate. I have informed general latency. What it requires has been captured here, and basically is it safety critical, or it is depending upon massive transmissions or something it requires is mentioned here. So if you see this, I think because the latency has reduced, because the massive transmission is possible, because there is a massive bandwidth available, all these use cases are becoming realistic, and These realistic use cases will make mobility safe and more. It will improve the life, and it will save people's life and make their commute more safe. I think that's about all I have, and I will hand it over to the Mark back.
Thank you, Kafshol. Now I perfectly understand why in your vita it says you are a connectivity system architect. You've proven on that. And also, what I also learned is that those sensors should behave like well-educated human beings. So listen and then talk. Yeah. Good. So let's jump into the panel discussion. I just learned that David can't make it shorthand, so it's Kafshol, Sanpech, and me. We will now also take questions from the audience. We already got some, and I saw that our Sanpech already answered one. Maybe we can just follow the F&A box and see whether we can kind of answer those. And then we also do free flow discussion. So David, sorry, Sanpech, there's one more question which maybe you can answer. The rollout of and development of 5G is a very interesting topic. Would you say that Thailand is ahead of neighboring countries in terms of rolling out 5G?
I'm not so sure if I can answer that properly, because I'm not a communication 5G expert.
Okay, then I take the question. So because we deep diving into this topic now around Beyond Mobile, I wouldn't say ahead. Thanks for the question, by the way. I wouldn't say ahead, but I would say you are very in that region, Southeast Asia. You are at the competitive edge. So Thailand, the government really saw that this is a utterly important topic. There are lots of pilots rolling out. There are lots of concrete kind of areas dealing with 5G business cases. And so what I see in my kind of, from the outer perspective here from Germany, is that Thailand certainly is one of those countries in the SEA region and even in the Asian markets, which is spearheading this development. But who wins the race doesn't matter. We as mankind need 5G, as we just learned from Kafshol, because it shortens the latency to 1 millisecond. And that again means that 5G is the first network which really is for machines and not for human beings, because we human beings, we can't really differentiate the quality of data between 4G and 5G, but machines can really kind of profit from that. So let's dive into that topic. Thanks for joining me for the panel discussion. As we learned from you, we kind of, there is a bold promise of 5G to the future of mobility and to smart cities and urban traffic management and so on. So Sanpech, your association has all those important players in it, I saw. Yeah. So what's the kind of vibes you're feeling from the talks and discussions of this topic? Not just electric vehicles, where 5G also plays some role, if you think about the connectivity issue there, but autonomous driving, which you really well displayed. What's the current kind of hottest topic, or what's the kind of debates you're dealing with in your association?
Okay, so I'll probably touch on this point, saying that right now at the moment in Thailand, the hot topic in general is probably regarding the EV as itself. Let's say only one part of the, let's say, the ACE or the case point of view. A lot of things are being talked about EV and how it's going to disrupt the automotive industry or the energy industry. Automotive industry meaning that, or the old kind of traditional OEM have to wake up quickly. There's a lot of let's say new players, the Chinese OEMs. There's a lot of new players in the, let's say, the charging of the battery kind of world. But the funny thing is that not a lot of discussion yet let's say in overall about autonomous sector. This is, however, being let's say addressed by the OEM themselves. I mean, the OEM themselves at the level of the headquarters, the design, the technology is being updated, and of course slowly being integrated to the latest vehicles. For instance, many cars are now capable of auto kind of cruise control, lane kind of changes. I mean, the extreme case, of course, Tesla, fully automated, or Waymo, fully automated, but those cases are kind of project being authorized by the government in cases like the US or some part of Europe, but not so much in Asia. So we are talking very much on let's say the EV side, not so much yet on the autonomous side. Hence, not so much discussion in general about the 5G connectivity, but this is being discussed, let's say, in the background within the OEMs themselves with suppliers. However, the interesting thing is that coincidentally, a few days ago, I happened to meet some kind of people from the industry, national telecom. So they are the kind of used to be a big, let's say, in the old analog world, they used to be important. So they were saying that they see applications, of course, autonomous vehicles one, and perhaps let's say in the case that we can have a doctor in Bangkok doing surgery, let's say virtually with a patient in Chiang Mai. Those are the kind of cases where you need very precise, quick communication, high, let's say very low latency kind of point of view. So those are the kind of application which I think could be interesting.
Yeah, I think probably getting pollution out of the cities is higher pressure. So this is why EV is such a hot topic, exactly, especially in those mega cities like Bangkok or Jakarta or whatever. And on the other side, of course, everything around us getting smarter. We had a webinar on smart cities, and interestingly, both David as well as Kafshol said, okay, there's a connection between us moving to more and more smarter cities and the upgrading of urban mobility with 5G and all those sensors. So Kafshol, let's talk about, before we talk about kind of V2X communication, whatever, as you are so deep into the topic, 5G also brings kind of a new paradigm towards edge computing, right? So the whole kind of intelligence goes to the edge. So can we talk about this a little bit, and how do we profit in terms of mobility from that edge computing?
Yes. So basically, the reliability is the big word. So if you say that, you know, it's not going to only, so 5G is not only going to impact just a driving mobility or something like that. There are lots of things called teleoperation. So the teleoperations are basically, let's say, the automation of delivery by robots, or there are so many things it is going to affect on. To your question, basically, if you take the terrestrial radio, which is connected to the device to the backend, it may not be 100% reliable at most of the time. It depends upon coverage. It depends upon where you are located. You are in a cellar or something like that. So basically, it has given a rise to and edge is anyway is a big buzzword or something like that. But it is very important because it will allow the computation and decisions to be made on the edge of the network, where the reliability of the device is much higher, while the major decision makings are happening in the cloud and making it more reliable. So if you look at the 5G, it has been defined ground up, and basically it has made most of the things as a service-oriented operations, And this services will have its own microservices on the edge, who are working under direction of the edge, the backend services, but they will be making more of the decision making when it comes to make a decision to act upon some information. And that's why the edge computing is becoming much more important in such a scenario.
And that's the fundamental probably difference to all other networks we had so far, yeah, like 4G,
Yes.
3G, and so on.
Yes.
Okay, got it. And with regards to vehicle to X, so you said there's, this car can talk to my device, it can talk to another car, it can talk to the grid, the network, the infrastructure, pedestrians even. So how does what's the role of Continental? So what kind of do you kind of sell products already in that domain, or is it early stage?
We already sell. So Continental as such is kind of a number one in connected car scenario. In connected car scenario, currently what we are doing is we supply industry a unit called telematics control unit. That is mostly going in all the new cars. And this is basically getting connected to the backend. So already the connectivity is there. Now, they are, so telematics control units host edge services, which takes decision to collect the sensors from the car and process them and upload them, or do a edge processing and computing and taking decisions to improve the reliability, or to improve the decision making for the cloud. Now, the V2, so these are sometimes safety services, sometimes services which try to take the data to improve the predictability of the sensors or mechanics inside the car. Or predictability of services when a car may need a service or something like that. But this also gives rise to safety issues in the car. So there are more and more customers now, as V2X is getting deployed at many places, are coming and asking more services, which are going to these telematics control units, which will make the life of mobility very safe. The deployments have already in some of the countries getting ready, but it is in the beginning stage, right at this point.
Okay, got you. So, Sampaj, if you listen to Kashol, you had this great chart of this consulting, I forgot who was it, case, yeah, McKinsey or whoever. So we talked about connectivity, we talked about autonomous driving, electrification, which is the topic of EVAD, and shared mobility. So do you have the feeling that in your association you need to kind of launch now new working groups to cope with all those topics? Because EV, of course, is your core, but you see that it's all connected, right?
Definitely, yeah, because it's a point of discussion that I've been kind of telling some of the members, saying that okay, cars are not going to be only concerning batteries, etc. It's going to be connected vehicles. I mean, as Kashal has said, I mean, we're talking about kind of automated service schedules, or these type of things. But okay, this is in the realm of maybe the OEM and the kind of and the suppliers kind of world. But we can add also other things on top of that. In terms of the autonomous sense, there's also a lot of potential kind of things that can be done. I don't know, we can have a new startup in the region instead of kind of big players getting into the field, because I really interested to see let's say a new kind of startup, new ideas coming up with let's say taking advantage of the new technology, the big shift in technology. Otherwise, we would always see the kind of the traditional players in the field.
You will maybe need to rename your association. Huh? So if you look at Thailand and Bangkok as a city in special, what do you see in terms of regulation needs? And, you know, I think David mentioned this as well. You know, it's good to talk about technique and latencies going down and bandwidth going up and so on. But I think every state has a set of rules of coping with this kind of intelligent things around us now. Yeah. So do you see something happening like this in Thailand and SEA in terms of talking about regulation, regulatory needs?
Actually, this is why I addressed that we maybe at the individual country, it's a regulation kind of issue, and maybe at the country level, the knowledge issue, because I happen to talk to some authorities concerning the energy service. They are, of course, trying to roll out a smart grid, but it's still kind of project phase, and to roll out further on, it takes a kind of justification at this stage. Of course, this relies on communication technology and also kind of paybacks in terms of, if you do this, what would you get in return? So those are the kind of point that they are questioning, knowing that in the future it makes a lot of sense, but maybe in the closer kind of immediate future, it's still not yet, let's say, the priority, maybe at the country level, I would say, but definitely these kind of things need to be addressed somehow in terms of regulation.
Okay, thank you. Kapshal, final question to you. You mentioned like 4 major use cases for 5G, and I think I got the last 2, like map updating and teleoperations and so on. But the first 2, I need to a little bit deep dive a little bit. So you mentioned high density platooning and see-through sensoring. Can you explain again what you mean with that?
Yes, I can. So platooning is one way. So let's say there are fleets traveling in the city, from city to city. So usually, if the heavy vehicles traveling, they will travel in a platoon because they will be heavily loaded and things. So usually, what really happens is that, you know, they really need to maintain the coordination between them. Because losing one out of them into somewhere and going and there are many use cases where they just can't afford to lose connecting each other, and those are the use cases where they are very and there are safety use cases there.
So this means that they kind of form an intranet for that moment, going from city to city or whatever, talking to each other.
Yes. The second one is very important. The second one is basically tries to tell you that see-through. So whenever there are 2 vehicles traveling to a junction together, and there are many of the places you will see that there are buildings in the corner that they will be blind actually. They will be completely blind to each other. And this communication will help and notify the user that there is, there are algorithms getting built on that, saying that, you know, how close is a close, and then how to inform each other, saying that, hey, you can't see, but there is a vehicle you can see that is coming your way, and that will avoid most of the accidents. That is what is envisaged actually. So these are the 2 use cases. Other use cases are seeing basically, let's say there are so cloud can do one thing, that basically if it collects the sensors, basically they build a peripheral database. So if there are 10 vehicles sending the vehicles out, so they can always map. Let's say from other direction there is an ambulance coming in. And you really want to give the way to ambulance in a safe, clear way. There are plenty of use cases like that, which is called see-through use cases, which will be improved by V2X. One, it will avoid the accident. Second, it will save the life by providing the safe passage to the to those kind of vehicles which needs faster access.
Okay, got you. Thank you for clarifying important use cases, as I understood. Yeah. So, gentlemen, this is already the end. We have one final question, which I can answer again. Anonymous guy, I really enjoyed the presentation. Can we expect to meet the companies and the speakers at the live event in June as well? Sanpech, Kavshol, you're cordially invited. I would say yes, right?
Yeah, we'll try. We don't know the situation, but
in Bangkok, and I guess I'm here. So
excellent. So this brings me to my last two charts. Thank you, gentlemen, for joining me this afternoon. So once again, we would like to highlight, and we already talked about this like a second ago, that we're doing this show in June 8 and 9. We doing it the first time. It's the only show globally, which is called Beyond Mobile. So we do it the first time in Bangkok, which is also a strong signal for that region in Southeast Asia. 5G will kind of revolutionize everything in the business context, as we just learned, not just future mobility, but also health and agriculture and lots of sectors. And we're doing this conference in the Samyan Mirton Hall in Bangkok. Please join us there. If you want to learn more, go to BeyondMobile.asia, sorry. And we have a final announcement. You can even see us live already before the show, because we're now starting a series of physical evening matchmaking events after work, 6 to 9. We call them Beyond Thursdays because they're happening on a Thursday. And the first one will be on February 10th in Seven Peaks office, the park. If you want to join, just scan the QR code. If you don't have your device now with you, just go to our website. You will find all the information about the first kind of meet and greet and mingle event in Bangkok on February 10 there as well. My name is Mark. Hope you enjoyed the show. See you next time. See you latest in Bangkok in June. And thank you very much.
Thank you very much, Mark.